As we saw in the provisioning phase of this course, CloudFormation works very well with infrastructure as code, allowing you to orchestrate infrastructure changes according to what you commit in the code commit repository. We also talked about CFN init, a feature that allows you to configure the instances as they are created by the CloudFormation stack. CFN init works very well for ephemeral environments, like dev test. If you want to change something, just change the CFN init in the CloudFormation template and then create a new stack. Then it will configure the OS of the instances that are created by that stack. And since you're going to have a new environment, that configuration should be done as soon as the stack is complete. After that, you can delete the previous stack, and CloudFormation will terminate the old resources. We can and we should use CloudFormation end-to-end. However, our production environments can be designed for more long-term run when compared to the dev test ones. Some of us work in an environment where we create and terminate it for every change. But what if what we want to do is a tiny change or an urgent OS patching? Sometimes we do have to create a whole new environment, and we are going to talk about deployment strategies in the next part of this course, but sometimes we just want to quickly change something. That's where AWS Systems Manager comes in. In simple words, AWS Systems Manager is a managed service that simplifies resource and application management, shortens the time to detect and resolve operational problems, and makes it easy to operate and manage your running infrastructure. But at this stage, we already have CloudFormation and CodePipeline in place doing that. So you should be asking what's the difference between CloudFormation and AWS Systems Manager, right? They are different services and operate in different scopes. So let me explain the difference. With Systems Manager, you can automate tasks on running EC2 instances. It provides some predefined automation documents for common operational tasks out of the box, but you can also create your own and customize to your own specific needs, such as installing monitoring agents, updating operating systems, adding existing Windows instances to an Active Directory in the main controller, and many more. Although you could do that with CFN init, Systems Manager operates on running infrastructure without having to destroy and create resources, a behavior done by default by CloudFormation because of the nature of how it handles infrastructure stacks. And since we may be maintaining fleets, we would like to have that kind of automation. Now, take the Active Directory scenario as an example. If you want to add a running instance into a domain controller, you will need some data, such as the domain controller IP address and credentials of an authorized ID user to perform that action. AWS Systems Manager has a feature called Parameter Store that can help you storing this key value content outside your source control, where you can store encrypted content to retrieve later. This is ideal for database connection strings, credentials, and anything you feel is sensitive data, because we don't want to have this kind of content in our code commit repositories, do we? The permissions for both AWS Systems Manager and Parameter Store are controlled by IAM, where we can write policies to restrict access to that information. You only pay for what you use, as you use it, with no minimum fees and no upfront commitments. AWS Systems Manager can do many other things. We will include some notes with links to the AWS documentation in the weekly readings. Let me do a quick demo to show you how to use the EC2 run command and parameter store in AWS Systems Manager. This is where you can find AWS Systems Manager on the AWS Management Console. We just type Systems Manager and choose the option from the drop-down menu. This is the AWS Systems Manager Management Console. And if you'll scroll here out to the bottom, you can see the parameter store. If we click on the parameter store, we have the option of creating new parameters. I'm doing these API calls with my user Raphael, which has administrator access in my AWS account. If I click on Create Parameter, I have the option of giving a name and a value to that parameter. So let's create a parameter called dbpassword. Choose as a secure string, which will be encrypted by a key management service encryption key, and assign a value into it. Then we click on Create Parameter. Now the parameter is created and part of AWS Systems Manager. IAM users that are authorized to interact with these parameters can retrieve them. I have my AWS CLI configured, and I just created a Python application that can get a parameter. This is the source code of that very simple application. It uses the Python SDK, and it has a function called getParameter, which is here. And I add into the variable option the input of the name of the parameter. Then I invoke getParameter, passing that option, and this will do the API call to US West 2 to parameter store to get that specific parameter. Let's run that application so as you can see it running. I can invoke it with Python and the file name, and then I can specify the name of the parameter that I just created. When I press enter, my application will do an API call to AWS Systems Manager and will get the parameter I just stored. You can see that the value of this parameter is ADX Training Rocks. Now let's see how you can use AWS Systems Manager run command to remotely run commands on your EC2 instances without having to log on them over SSH. Here I have my EC2 instance that runs my Flask application. Actually, the application is not running right now because I think the web server crashed. So if we get the public DNS name and put in a browser, that's what we are going to see. This site can be reached. So let's fix it with the help of AWS Systems Manager with the run command option. In order for this to work, I need to have the SSM agents installed on the instance. And this documentation page is pretty straightforward on helping me how to install and configure the SSM agent, both on Windows instances and Linux instances. Ideally, you would like to have this agent installed automatically. So this documentation page also shows you how to install the instances on the boot time. I just followed through these steps here. There are some commands. I put these commands on an SSH window, and that was the last time I actually connected on that instance over SSH. I can even go to the EC2 instance's security group, which has the port 22 open, and close it. So let me select the security group. Let me extend this pane here. Inbound, edit, and remove the SSH ports. Now this instance does not have port SSH open anymore, because the security groups applies the principle of least privilege, and if a port is not explicitly allowed, it is implicitly blocked. Let's execute the command using AWS Systems Manager to see it in action. We can go to AWS Systems Manager and click on the option Run Command, which you can find here on the sidebar. When you press that, you can go to this screen, and then you can see the Run Command option. The command we want to execute in this case is a service nginx start, which is the command that will install our web server. So since it is a Linux command, I can search for document name prefixes that are equal AWS run shell script. And there it is. And here it is, AWS run shell script. Now, since this instance already have the SSM agent installed and running, we can specify the instance just by selecting it here from this menu. Notice that I could execute this command on multiple instances at the same time, just by selecting them. In this case, I just have one instance. I could also specify a command to be executed on multiple instances at the same time by using tags. So, if I want to urgently patch my operating system on all instances that are on the production environment, if they are appropriately tagged, I could do that with Systems Manager. For now, let's just execute manually in one instance. That instance should also have an IAM role associated to it. Let me show you the role here by going on Instances, Flask Application, IAM role. This is the role that I have attached to my instance. If you don't put that role, actually Systems Manager won't know that it is running on that instance, and then the instance won't appear in this drop-down menu. This IAM role is very simple, and it's a role that has an AWS managed policy called Amazon EC2 role for SSM. I created a role with the name SSM role, and I just associated with that instance. If we go back to AWS Systems Manager where we were, we can specify the commands that we want to execute here. There are some extra options here, such as the comment for this specific command, the rate control if you want to execute in one instance at a time or in 50% of your instances at a time, for example. You can have SNS notifications and some output options, such as writing the command output to an S3 bucket for further auditing. If you click here, it expands the command line interface command that you can execute on your laptop or in any AWS instance that has the AWS CLI installed that you could use to manually do that command execution. For now, I'm going to use the AWS Management Console, but you would like to automate that and even create a tool so as you can remotely execute commands without having SSH agents installed and configured. If I click on Run, this command will be executed on my instance. It's in progress now, but if we go back here to the Run command, we can see that it actually has been already executed. And that's actually interesting because you can have a paper trail of all the commands that were executed on your instances over time. If we click on this specific command ID, we can scroll down and see the outputs. Now, if we go back to that instance, probably the web server is now running. If we refresh our page, then we have our application. And remember that this instance does not have port 22 open anymore. This is how you can actually use AWS Systems Manager to leverage administration of your running instances without having to open administrative ports on your firewall, such as port 22 or 3389 in case of Windows instances.